Hi, and welcome to this segment of Maths exam questions on probability. Question 4. A bag contains green balls and red balls only. A ball is taken at random from the bag. The probability of taking a green ball is 0.38. Write down the probability of taking a red ball. I'm noting here that the probability of taking a green ball is 0.38. With the bag containing green balls and red balls only, the probability of taking a red ball is therefore the remaining probability. What now is the probability of taking a blue ball? The bag does not contain any blue balls, so the probability of taking a blue ball is 0. Question 15. A box contains 22 colored pencils. 6 pencils are pink, 9 pencils are blue, 7 pencils are yellow. Write down the ratio of pink pencils to non-pink pencils. Give your answer in its simplest form. The ratio is 6 to 16 and in the simplified form 3 to 8. Next, a pencil is taken at random from the box. Write down the probability that this pencil is green. There are no green pencils, so the probability is 0. Question 6. The probability that Alex wins a prize is 0.27. Find the probability that Alex does not win a prize. This will be the remaining probability that adds up to 1. Question 11. The diagram shows 5 cards. 2 of the cards are taken at random without replacement. Find the probability that both cards show an even number. In such an event, we start off with 5 cards. At this point, the probability of getting an even number is 2 over 5. Having picked the first card being an even number, we're left with 4 cards. From here, the probability of getting an even number has now become 1 over 4. Therefore, the probability of both cards showing an even number is the product of 2 over 5 and 1 over 4, which equates to 1 over 10. Question 20. 40 children were asked if they have a computer or a phone or both. The Venn diagram shows the results. A child is chosen at random from the children who have a computer. Write down the probability that this child has a phone. This is 8 over 15. Next, complete the Venn diagram. The logic would see to each of the numbers being positioned in accordance to the arrows. Question 2. 80 students each record the name of their mathematics teacher. The number of these students taught by Mr. House and Ms. Patel are shown in the bar chart. How many more students are taught by Ms. Patel than by Mr. House? From the bar chart, this would be the difference between 18 and 14. Question 2b. 15 students are taught by Mr. Smith. Twice as many students are taught by Mrs. Brown than by Mr. Jones. Use this information to complete the bar chart. The blue bars on the chart represent the information that completes the bar chart. Next, write down the mode. The mode will tie to Mrs. Brown as this has the highest frequency. Question 2d. One of these students is chosen at random. Work out the probability that this student is taught by Mr. House. This probability is 14 over 80 and in simplified form 7 over 40. Next, work out the probability that this student is not taught by either Mr. House or Ms. Patel. This probability is 48 over 80 or in simplified form 3 over 5. Next, this information is also to be shown in a pie chart. Work out the sector angle for Ms. Patel. This will be the ratio of 18 out of 80 against the angle of 360 degrees. Question 6. Given there are 240 students in the school, with 120 students playing football, 40 students playing baseball, and 90 students playing football but not baseball, complete the Venn diagram to show this information. Here, the sequence in completing the Venn diagram is crucial. Step 1 involves documenting the 90 students playing football but not baseball. Step 2 involves documenting the remaining 30 out of 120 students playing football. Step 3 involves documenting the remaining 10 out of 40 students playing baseball. And finally, step 4 involves documenting the 110 out of the 240 students in the entire school. Next, find the expression. The expression represents students not playing football and not playing baseball. This is 110 on the Venn diagram. Next question. A student in the school is chosen at random. Find the probability that this student plays baseball but not football. This would be 10 out of the total population of 240, and when simplified becomes 1 over 24. Next question. Two students who play baseball are chosen at random. Find the probability that they both also play football. The probability of a student that's already playing baseball that also plays football is 30 over 40. When choosing two students in succession of this manner, this probability is 30 over 40 times 29 over 39. Question 3. The probability that Andrea cycles to school is R. Write down in terms of R the probability that Andrea does not cycle to school. This probability is 1 minus R. Next, the probability that Benoit does not cycle to school is 1.3 minus R. The probability that both Andrea and Benoit do not cycle to school is 0.4. Complete the equation in terms of R. Equation is 1 minus R times 1.3 minus R equals 0.4. Next, show that this equation simplifies to the stated equation. Here, we'll start with the equation stated in B1. Then, expand on the equation, scale it by 10, and rearrange it to get to the required equation. Question 3. Solve by factorization the stated equation. Through factorization, R is 1.8 or 0.5. Next, find the probability that Benoit does not cycle to school. With probability only being meaningful as a positive number, the only applicable R is 0.5. This makes the probability of Benoit not cycling to school being 1.3 minus 0.5. Question 8a. Angelo has a bag containing 3 white counters and X black counters. He takes 2 counters at random from the bag without replacement. Complete the following statement. The probability that Angelo takes 2 black counters is... Being without replacement, both the numerator and denominator of the second fraction is just 1 count less than that of the first fraction. Next, the probability that Angelo takes 2 black counters is 7 over 15. Show that the stated equation is true. This can be shown by equating the expression in 8a1 with 7 over 15 and rearrange accordingly. Next, solve by factorization the given equation. This leads to x being 7 or minus 3 over 4. Next, write down the number of black counters in the bag. In this case, x must be a positive number, and that makes it 7. Question 8b. Esme has a bag with 5 green counters and 4 red counters. She takes 3 counters at random from the bag without replacement. Work out the probability that the 3 counters are all the same color. Here, the required answer is the sum of the probability when all 3 in succession are green and when all 3 in succession are red. This comes to 1 over 6. That's all for this segment. Do get into our other videos under KT Tutorial channel if you've liked this.